Hey everyone, I'm John McCutcheon.
I'm Todd Turnage. We're both developers on the Dart VM team.
Yep, and we really care about the developer experience. So we're really excited today to talk to you more about Hot Reload and a new feature that you haven't seen yet, Rewind.
Yeah, you saw some nice demos of that with Eric's stuff already. We're going to go a little more in depth on them and maybe a little slower on some of that.
Yeah, so what we're really here to talk about today is changing the way you change your Dart code. And so we're going to start off with two demos. We're going to show Hot Reload, and then we're going to show Rewind. So let's just get straight into the demo. So here I am in Atom, and I have the Flutter gallery running on the side. You're already familiar with Flutter gallery. So what I've got here on the left-hand side is the source code for the calculator demo inside the gallery. So this is your standard calculator, add, subtract, multiply, divide, 0 through 9. And as you saw, Eric showed that you can very quickly redesign your UI. So what I'm going to do is I'm just going to add 10, 11, and 12 to the calculator.
Yeah, so he's just copying this little bit of code, and he's going to change the 7, 8, and 9 keys to 10, 11, and 12 keys, and then hit reload, and there you go.
And as you saw before, you could also, maybe you want to change the color of the buttons. You do that.
Now, at the bottom here, it says reloaded 7 of 440 libraries. You want to say what's going on there?
Yeah, so what we're doing in the back end of the VM is we're actually figuring out which one of your libraries have changed or are transitively affected by the change, and we only reload those. And so this reload that we just did there took 285 milliseconds, and we only reloaded 7 of about 440 libraries.
Yeah, so let's talk about what 285 milliseconds means. I mean, when you're developing, if something takes 2 minutes, you go away and you do something else, you get distracted, whatever. 285 milliseconds, as you saw, you're able to make change after change after change, and your tools aren't getting in your way. You've got a nice, tight development cycle.
This is the true time from the moment I press the request for the reload all the way until the frame is rendered on the device.
Yeah.
We're not skipping anything here. This is the true time from when you press the button in your IDE to when you can visually see it in the app.
Yeah. And when did we start working on that? Like back in March or something?
May.
Yeah.
Yeah. It's been one fun summer.
Yeah.
So let's take it a little bit further. And why don't we add the mod operator to calculator? We're all developers. We all have mod. For some reason, calculators have forgotten about it. So I'm just going to go ahead and I added a new key. And I'm going to ignore this error here that the analyzer is warning me about, telling me, hey,
Yeah, forget that. You're smarter than the analyzer.
yeah, the handle mod tab, that's not implemented. And as you can see, we get this, this red widget of death, which is what happens when one of your build functions inside your Flutter app ends up throwing an exception.
Yeah, except death is now in quotes, right?
Yeah, because in the reload world, we can bring your app right back to life. So I'll just start by copying the implementation of plus, and I'll just rename it to mod.
So now we're not just changing little bits of code. We're adding new functions. We can add new classes. We can add lots of things.
You can import new libraries. You can unimport libraries. You can delete classes. There's lots of things you can do here. But now
we should actually get something in our accumulator here.
Yeah, all right. So let's do like
8 times 11, maybe.
Yeah, let's somehow clear that out. That might get too big. All right. So there's the 10 button working.
Yeah.
Now I've wired up mod to do something, but it's really just going to do plus. All right. The button works, but let's take it one step further and actually finish the implementation of mod in the calculator. So you can see here that the way the calculator is structured is that you pass in the operation kind when the button is pressed. So I'll just go ahead and say I want to do a mod operation. And here's the static analyzer telling me, hey, there is no mod defined for this enum.
At this point, the workflow sort of looks like you follow the breadcrumbs that the analyzer left you until, as Kevin was talking about earlier, the red squiggles all go away.
Yeah.
And
so what I've done is I've added mod to the enum, and that's okay in a reloaded world. But now I'm just going to follow along, and there's many switch statements that I forgot to include mod for. So this is what the mod operation will look like on the screen. percent. Just use the analyzer here. Now, down here, this is handling addition and subtraction.
So mod is like multiplication and division, so we'll handle it the same way.
Yeah. Now, down here is where I'll actually go ahead and implement mod, and Todd will talk about what I'm doing.
I think we should see if Eric can actually add the 10 and 11 and 12 key to the calculator for real, so save us all this time.
Yeah.
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 Is it looking clean? Oh, not quite yet. Yes, actually, he's going to implement the mod operator. Current value mod equals X number.
And we'll put an else there. Okay. Just do a reload.
Boom.
There's no visual change here, but that reload took 265 milliseconds. And
It's essentially
let's
instant.
see. All right. Okay. It looks like it's working. There it is. So what we've seen here is more than just editing the body of a function. We added methods, we crashed our app, we brought the app back to life, we added a new enum definition, and we fully implemented mod in this calculator, never restarting it. And
We've kept their state the whole time.
yeah, and each step along the way took about 285 milliseconds. So there's no more XKCD compiling memes in the Flutter world. All right, so that's the hot reload demo. Todd's going to talk about rewind.
All right, so rewind is a feature that we're working on that plays very nicely with reload. It's not quite implemented in Flutter yet, so I'm going to demo it on just a standalone Dart VM today, but it'll be coming soon. I've written a text adventure game. Those of you who've seen my demos in past years know I always have written a text adventure game. All right, so you're in a mysterious chamber. There's an exit to the west. A deadly mousetrap lies nearby. So I'm going to go attach the observatory debugger to this. Let's add a tab and go to localhost.
So what is observatory?
Observatory is a set of tools that come bundled in with Flutter or with the Dart VM that allow you to do just a ton of stuff.
CPU
Like what kinds of stuff?
profiling, allocation profiling. We have a new timeline feature this year. Debugging.
Yeah, in this case, I'm going to use the debugger, and I'm going to tell it to turn on break on exception, so that if I hit an exception while I'm running my text adventure game, it will pop into the debugger. Now, do you think I'm likely to hit an exception in my game?
I've seen this demo before, Todd. You're
All right.
definitely going to throw an exception.
So I'm going to go west, I'm going to go south, I'm going to take the oil can. Now, the oil can can be used to oil an object to make it not rusty, like the rusty revolver, which I'm not holding. And so I'm not holding the revolver, and I've gotten this no such method. All right, so you run into no such methods a lot if you're a Dart developer, and usually it means what?
Your program is dead.
You restart your program and try again. And you sort of, you have to sort of do this post-mortem thing. So let's look at this stack trace here. We've got object no such method, called by another no such method, called by my do command. And what the rewind feature does is it allows us to take any function call and rewind back to the call site that called it, so that then we're sort of going back in time and we can run it again.
Now, what happens if there's side effects?
If there's side effects, we don't undo the side effects. So this works pretty well with a function that's relatively side effect free. You can go back and sort of walk through the steps again to see why you crashed. So I can rewind. And I could rewind again even, and I could see, oh, I'm here, I'm doing this thing.
So the program has actually moved its execution point back to this function.
Yeah, I'm just about to do the call. If I want to do the call again, I can just continue, and I can hit my exception again, you know?
Right.
Or I could rewind, and I could step back into the function. So let's actually use this for some purpose. I'm looking at my code, and I'm like, boy, I wonder what the value of the item 2 is there. So I'm going to go to Emacs, king of editors, and I'm going to print value is $ the item 2. So I'm just adding some code in here.
It's classic printf debugging.
Yep. I'll save it. Now I'll go back over here and I'll reload. So I've reloaded the code. If I start rewinding though, I see that I still have the old code in do command. That's kind of bad. Well, it's because I was in the middle of running that function. It was in the middle of running the old code. In order to get the new code, I need to enter the function again, which means I need to rewind one more and go back in.
Yeah,
So,
we'll talk a little bit more about that later on in the talk.
so I rewind, and now I'm going to just step into do command. And you notice the pink along the edge there? That's code coverage. This is the first time we're in this function now.
This version of the function.
This version of the function. And if I look down here, I see that the print will be done. So let's just continue and see what the value could possibly have been. I hit the exception again, go back over here to my text adventure game. It says, oh, the value is null. All right, I have a null in my program. Let's just fix this thing. So if the item 2, I have to sing when I code. It's really hard for people in my office, equals null, then John wears headphones a lot,
Yeah,
actually.
noise canceling.
And then, so if it's null, I'm going to give them some sort of a
How about
message.
you say you can't oil that?
You can't. I'll say you can't oil that. I'm going to say you cannot oil that.
All right. Be verbose.
Exclamation. Yeah. This is my game. So I'm going to go back here, and I'm going to reload this.
Yeah, so we got to rewind past the point.
Yeah. So let's start rewinding up frames. I'm rewinding up frames, and it
And
just
can you
sort of
rewind
works.
like with, an n number of frames?
I can. You can say rewind 3 or something if you
Nice.
want. That
Yeah.
works. Yeah. And so let's rewind one more and step in. And now it looks like I have to sing again. Yeah, there's this you cannot oil that right there. So what do you say we continue the program and see if it's all good? Back here, and it says you cannot oil that. So I've fixed my program. This is called fix and continue debugging.
Yeah. It's
We're
the
able to-
combination of...
So the combination of reload plus being able to just go a little bit back in time means that you can get yourself into a weird, bad neighborhood of your program. Someplace where before you just got knocked in the head and you had all your stuff stolen.
Yeah, you wake up the next morning, you're like, what happened?
So instead, you can, while you're there, you can say, I'm going to make this right. And you have sort of your Groundhog's Day moment where you just
Yeah, you can just
redo
keep
events again and again
cycling
until you
that.
get it right. Fix your problem, and then you go on. So you don't need to go through your 15 minutes of setup that it took.
Yeah, I mean,
Whatever.
Todd did like 3 actions here, right? West, south, take the oil can. But in a larger app, you might be like 10 pages deep into your mobile app. Your app has downloaded a bunch of assets off the network. And getting back to the state to reproduce the bug may take a minute or 2. But with rewind and reload combined, you can just hang out right around the place where your bug is.
All right.
Okay, so we've just given you a demo of hot reload and rewind combined, but let's take a step back and just look at what this new dev cycle looks like.
All right, so you're programming, and occasionally when you're programming, you find a problem with your program. We both found problems. He had a function he called that wasn't in his program, for example. He got this red screen. And so we change our program, we just reload, and then
Yeah, and then what happens, the VM gets the reload request, it determines which libraries have changed, and then it just reloads those libraries.
now, sometimes the reload won't work for some reason, right? Like maybe you have some, it's not really dark code you put into the file or something.
Yeah,
You know what I
maybe you
mean?
pasted some JavaScript in. But yeah, the
what
reload
happens then?
it's safe. We detect at reload time if the reload is acceptable to apply or not. And if we decide that it can't be applied, we just put the old code back in place and we just let your program continue as it was.
Yeah. We want to take this cycle and make it as tight as we possibly can.
Yeah.
Remove as much of this annoyance of development.
So now for Flutter applications, we follow up reload with a couple extra steps. The first is that we ask the Flutter app to reassemble itself. And what this means, practically speaking, is just all of your build methods get reinvoked. So the new widget tree gets passed down to the renderer, and that gets rendered on the screen. And we just follow that up again with a forced frame. So this is how we get the Flutter app, after reloading the code, to reassemble the UI.
In the way the Flutter framework is structured, we won't go into it, it's particularly well suited to work well with reload in this case.
Yeah, I mean, the Flutter framework is functional, right? And what we're talking about is updating the body of functions.
Okay, it helps to have just a little bit of intuition about how reload works if you're going to be doing development against it so that you're not surprised. First, let's talk about sort of naming and identity. I have some set of code that I'm reloading, and when I load it in, I get a library, and the library might have some URL. it will replace whatever original library had the same URL. So the library's URL is important for determining what the replacement is for the original. In the same way, if I have some class with the same name as a class that existed before, and it happens to be in the same library,
Yep.
then we replace that class. So
It's fairly intuitive as a developer. I mean, libraries are loaded in Dart by URL, and we just keep these naming and identities along the way. Now, the most common question we've had from all of the developers who've been playing around with Hot Reload for a while is, what happens to my static data? And if you look at the top of the slide here, you can see that there's this list X, and it has this initializing expression of just a list of 1, 2, 3. Now, the VM is only going to run this initializing expression once. And it depends, like when your program first accesses X, that's when the initializing expression is going to be run.
So if we did it once before a reload,
It would be 1, 2, 3. But if you reloaded first and then accessed X, you would get 4, 5, 6 as the initial value. And the key takeaway here is that code is reloaded, but data isn't. So X does not automatically update, but luckily you have a debugger, and you can just go into the debugger and change X to be whatever you want.
yeah, basically you keep your heap across reloads.
Yep.
So whatever's there is there. All right, so let's talk about function calls. We saw a little bit about this in the adventure demo. So we have some activations on our call stack. I call main, it calls some other functions, and we activate a reload. We trigger a reload. After the point of the reload, all new function calls will use the new code. But the existing,
Yeah, the existing code is gonna stay there and run until it comes off the stack, which
Yeah.
is where rewind becomes so powerful.
right, so if we called foo recursively here, we'd have a new version of foo on the stack at the same time as an old version of foo. And so that's why, yeah, again, you need rewind sometimes, because if you want to force executing the new version of the code during a debugging session.
So when Dart was first designed, one of the explicit design goals was to not allow you to change the shape of an instance.
And by shape, we mean the number of fields.
Yeah. How many fields is in your class? That is locked down the moment your program runs. But in a reload world and in this live development world that we have today, we want to support changing the shape of instances while your program are running. So you can add a new field in reload. And what we do is we end up going through the heap. We find every instance of that class. We grow it, and we put null in to where that new field is. And deleting works the same way,
Yeah.
except we just shrink it. So we just scan across the heap. We find every instance of the class, shrink it down, and whatever values were in those fields, in those instances, they're just garbage, and the GC will take care of them for you. Renaming fields is not supported. It's just treated like a deletion followed by an addition.
Yeah, an IDE could maybe, if we have enough context, we could do renames, but for
Yeah.
now, it's just additions and deletions.
But reordering works fine. Like we use URLs and class names, we use field names for matching and pairing them up. So if your class goes from listing the fields as XYZ to ZYX, everything will be fine.
We'll just swap them all around in memory.
Yeah.
Okay, anonymous closures. In bold here, you see an anonymous closure that is adding two numbers. And after reload, maybe it subtracts two numbers. Well, the closures get captured at the time that they're created. So it's not like just because you did a reload that this closure that you've created is going to change. It will continue to be plus after the reload, even though you've changed it.
So this means that you could end up in a state where they're both
Yeah,
alive.
you could easily have like essentially two anonymous closures, which are in some sense the same. They're created at the same point in your program, but they're different because they were created at different times. It's just part of how closures work.
Yeah. Anonymous closures.
Anonymous closures.
Now, tear-off closures, these are like methods that are attached to an instance. These always use the latest code. And this is because when you invoke a tear-off closure, there's a level of indirection that it steps through, where it's really attached to the name of the method and not the source code that was in the method at the time. So in this code example on the slide here, you can see that I first start off with my on-tap printing 1. I make a tear-off closure. I reload. It now prints 2. I take another tear-off closure. Now both of these tear-off closures print 2.
Yeah. This works pretty nicely when you're doing reload as part of your development cycle, these tear-off closures. They just
Yeah,
sort
'cause
of
these are-
update themselves.
Like handle mod tap
Yeah.
earlier, that's a tear off closure. So every time I make a change to handle mod tap, the app is going to respect that and see that. So Dart now supports live programming with a less than 1 second edit refresh cycle on mobile devices.
Yeah, we've got this rewind feature coming soon, which is going to give you the ability to fix and continue.
So yeah, try Flutter today. We're really excited for you guys to try it out. Just finally, we just want to say that this wasn't just Todd and I working on this. Ryan, and who's also on the VM team, and Ian Hickson, who's on the Flutter team, have been very important in making this happen, as well as many other people on both teams for bug reports and fixes. Thank you.
Yeah, thanks.
You guys did an excellent job of finishing in time to do a little Q&A, if you would like. So we have a couple minutes while they get set up. Do you guys want to answer some questions?
I'd love to answer
I like
some
just putting you on
questions.
the spot like that. Is that okay?
That's fine.
Yeah.
You guys have any questions?
I'm waiting for like the SNL thing. Like, so what you guys did was awesome. Is that a question?
How awesome.
How awesome? Exactly. Is this feature cool or the coolest feature?
You guys want to just grab us on, out of the context, you can do that too.
Yeah, that's also okay.
We got a question.
Okay.
There is a question about memory leaks and how many memory consumption and this feature too.
Well,
Because, nowadays, MapStore, for example, leaks so much, and especially on Linux.
Can you repeat the question first?
yeah, he was asking if we have problems with memory leaks.
Yeah, hot reload as implemented.
Is your thing still on?
Thank you. It's not. Hot reload as implemented in the VM does not leak memory.
Yeah. We create all these new libraries, and then the old libraries, we just unlink them, and the GC takes care of them.
Yeah.
I mean, all of our libraries and code and stuff is all in the heap. And so once we're not using it anymore, like on the call stack, it goes away.
Yeah, those old code objects will just be GC'd after the activation exits.
Yeah.
Right, and about Flutter framework, Flutter applications in comparison with native applications. What about memory and CPU?
We're not the right people to answer that question.
Yeah.
Find Eric and Seth. We can talk about that.
Yeah, we work on the VM and reload.
Thank you.
How much of that functionality can be reused for headless.vm, like the hot reloading? Is that something which is going to come to?
Oh, it's already supported.
Okay.
Yeah.
The question was for that. Does this all work in the headless Dart desktop VM as well as Flutter?
Yeah, the server
Yeah, I was
VM.
demoing it with the adventure game, and that's basically the headless Dart VM. There's a couple of commits that need to happen when I get back to Mountain View.
Yeah.
But
Yeah. So for IoT development, running .vm on IoT devices,
Yeah.
you could do exactly the same thing.
yeah.
Yes.
And please send us bug reports if you find any problems.
Yeah, that'd be
Yeah.
great.
Yeah.
Should we do one more question? 0 more questions? Let's get it going. You guys ready for the next talk?
All right.
All right.
All right.
Thanks a lot, guys.